Hey guys, welcome to 4.1 Graphing Systems of Equations. So, this unit we're actually just going to talk about systems of equations, which means that basically we're just going to have two or more equations that we have to solve together. So, we want to know what the answer to both of them put together is at the same time. Okay? And we've kind of already done this a little bit where when we did absolute value equations, we just had to solve two. The solution to these is the point that's on both lines or where they cross, okay? And that point, written as x comma y, has to make both equations true, okay? So there are three options you have here. We've seen these three things before. No solution, one solution, infinite solutions. No solutions means two lines that should never cross, like this. Okay, so that's parallel lines that never cross. One solution means that they are intersecting, or they intersect, which means they cross once. And that one point, wherever it's at, is your solution. Infinite solutions means you have two lines that are on top of each other. So this is really actually two lines, you just can't see it because they're both right here. So that's the same line, which means they are always crossing. So no solution means parallel lines that never cross. Infinite solutions means, oops, it gave me the same equation twice. That means they're the same thing, and they're always going to be the same thing, so they're always crossing. They are crossing to infinity and beyond, basically. What we're going to do today is basically graph both lines and find out where they cross and write the answer as an ordered pair x comma y. Now, this part is the two forms that you will see the lines in. If it's in y equals mx plus b, start at the y-intercept and follow the slope. If x and y are on the same side like this, find the x-intercept and the y-intercept and then connect them. Some of you are honestly doing better at that one than you are this one. Let's take a look at what this will actually look like. So this is the point in the video where I'll start saying, this is part of your assignment. I'm going to do the first two right here, and then I'm going to let you guys go type these two into yours. Okay? So this top line is 4 over 3x minus 5. That 4/3 tells me to put my y-intercept at the negative 5 tells me to put my y-intercept at negative 5. And then the 4/3, remember that the part on the top is called the rise, and the part on the bottom is called the run. I don't know, my writing skills are not the best right here. So that means I need to rise 4, run 3 to the right. So from my point, my y-intercept, I'm going to go up 4, right 3. And that's my first line. The only thing is, guys, you need to make sure that your points actually go through that line because you're going to want to find the intersection in a second. The other line is going to start at 2 because it's got a plus 2. And this one has a slope of negative, well, there's no number out there. If that bothers you, you can put a negative 1 over 1, which means you're going to go down 1, right 1, like that. And then make your line go through it. But you want that line to go through it and beyond to make sure that you actually get to the other line, like that. And you can see now that these two lines cross right here at the point 3, negative 1. So you're going to double click this and write it as a point 3, comma, -1, in parentheses, because that's how we write points. Over here, I'm going to start at up 4, and I'm going to go up 3 over 1, which means my next point will be right here. I'm going to put one of my lines through those 2 points. Perfect. And then my other line starts at -2. Okay, and it also is going up 3 over 1. Well, look, if I go up 3 over 1, but I start at -2 instead of 4, guess what? There's no way that this line is going to catch up to the other one, because they're going up at the same rate. That's why parallel lines have the same slope. So if these have the same slope but different y-intercepts, they're never going to cross. So this is a no solution example. Okay? What I want you to do now is pause the video and go work on the next 2 slides. So that's 4 problems, guys. And then come back to me when you're ready for slide 7. Okay, you should have finished slides 4 through 6 now, and you should be ready for slide 7. So here's how slide 7 works, and the reason why it's a little different. This equation doesn't have y equals. So what we're going to do is cross out our y's for a second, and I have 2x equals 10. Well, if I divide by 2 on each side, that's going to mean x equals 5. So I'm going to drag this point over to where x is 5 on the x-axis. And then I'm going to erase that, and I'm going to cross out the x's instead. And this time I need to divide by -5 on both sides. Well, 10 divided by -5 is -2. So I need to put a point at -2 on the y-axis, like that. And that's my first line. And I know sometimes these are kind of hard to draw your line through. There we go, close enough. And then the other one is in slope-intercept form. It has a +1 at the end, so I start at 1 on the y-axis. And it doesn't have a number in front of x either. Remember that you can always put a 1 out there. You can always add a 1 on the bottom if you need to see that. So this line is going up 1 over 1 to the right, like that. And it doesn't look like this one's going to cross for a second, but just hang on. Because if I make this line, like, look, that goes through my 2 points, but I need it to be bigger so that it actually goes through the whole thing. So if you hold down the shift key and you keep dragging it, it won't change the slope, but it'll make the line bigger. And my line is a little off. This right here is supposed to be the point where they cross at -5, -4. Okay, and you can always kind of assume that that's going to be in a nice spot. Okay, so -5, -4 is my answer. And I know this is way more difficult on the computer than it would be if we were in person. You're welcome to draw the graphs on your own if you really want to. And then over here, I'm going to do the same thing. If x and y are on the same side, cross out the y's, find your x. 12 divided by 6 is 2. And then I'm going to do the same thing, but for my y's. -3 is in front of the y. 12 divided by -3 is -4. And then I'm going to draw my line through those 2 points. There we go. And then the other one has -4 at the end for its y-intercept, which, hey, look at that. And then it's going to go up 2 over 1. Wait, look at that, guys. Wait, hang on, move my point at the very end. That's the same line. See how these 2 points are in the same exact spot? They were already on the line that's there. This is an example of infinite solutions. Okay, so they were the same line. It didn't look like it because the equations are in different forms, but they ended up being in the same spot. That's what infinite solutions looks like. Now, go ahead and try the next 2 slides on your assignment and then answer the last 2 using the graphs. So the graphs are already done for you. You just have to identify the solution.